Okay. So therefore, we studied center of mass and we studied moment of inertia. So next we are studying the very important topic which is called as rotational dynamics. Okay. So one of the toughest topics of physics, but we will try to understand in the most simplest way as possible. Clear. See here. So previously we studied about circular motion. Okay, now we are studying about rotational motion. Are you able to understand? Previously we studied circular motion, horizontal circular motion, vertical circular motion, all we have studied. No? So now we are studying rotational motion. So what is the difference between circular motion and rotational motion? Can you say? Difference between circular motion and rotational motion is what? Is there any difference or no difference? Yedo sardaga rendu perlu pettukunnava. Difference is there. What is the difference? ఏ బాడీ అయినా యాక్సిస్ చుట్టే తిరుగుతుంది. ఇదేమి డెఫినేషన్ రా బాబు. See, circular motion means we take a single point. Understood, no? Single body and it is moving in a circular path. This is called as circular motion. Are you able to understand? Rotational motion means we take a rigid body. Are you able to understand, ma? So rigid body. For example, disk is a rigid body, no? Disk is a rigid body. So if this total disk is rotating about this axis with an angular velocity of omega, then this type of motion we can call it as rotational motion. That is the difference. Understood, Nama? Circular motion means just a single particle if it is moving in a circular path. We are tying a stone to a thread and we are moving in a circular path. That is called as circular motion. Whereas if I take any rigid body and rigid body is rotating about an axis, then it is called as rotational motion. That is the difference between circular motion and rotational motion. Are you able to understand, ma? Okay, now see. For example, if I take a disk, okay, ma? So this is a disk. Understood, no? So this disk, it is rotating with an angular velocity of omega. Okay. So first of all we will study some parameters, ma. So consider here there is some point P. Okay, ma? So this is a point P which is present and this is the radius of this disk. Now this disk is rotating with how much angular velocity? It is rotating with an angular velocity of omega. Then after a time of t seconds, same point P, it will reach up to here, no? Are you able to understand? This point, it will reach here after some time, after some rotation. Are you able to understand? What is the angle covered by this particle? Angle covered by this particle is theta. Okay. Then what is this theta called as? This theta is called as angular displacement. That is what we call this, Noma. Theta is called as what? You can call it as angle rotated also, or you can call it as angular displacement also. So that is the angle rotated by the particle. Okay. So for this rotation, it will take some time of t also, no? Okay, ma? So body has rotated by an angle of theta, or angular displacement is theta, in how much time? In a time of t. Are you able to understand? So therefore, change in angle divided by time taken. Can you say what can I call this one? How much angle the body has rotated in a particular time. What is this called as? This exactly is what is called as angular velocity. Understood, Nama? So in linear motion we study, Nama. For example, this is a point mass, okay, and it has covered a displacement of s. What is s here? Displacement. What is theta here? Angular displacement. Both are same. Understood, no? Displacement in linear motion, angular displacement in rotational motion. Understood, Nama? Displacement by time is called what? How much body has displaced in how much time? That ratio is called as velocity. Understood, no? Similarly, same concept here also. How much angular displacement the body has covered in how much time? This ratio is called as angular velocity. This is linear displacement, linear velocity, angular displacement, angular velocity. Okay, how much angle the body can cover in 1 second. That is called as angular velocity. Understood, no? So omega is called what here? Angular velocity. Are you able to understand, no? So now again you come to linear motion. If velocity of the body is not a constant, if velocity of the body is not a constant, then what we say? Body velocity constant ga ledu anukondi. What we call that kind of motion? Aటువంటి motion emantam? We call it as accelerated motion, or we can call it as non-uniform motion. Okay, ma? So how can I define linear acceleration? A can be written as change in velocity divided by change in time. Okay, instantaneous acceleration. Are you able to understand? Or if you want to calculate average acceleration or general acceleration, then how can you calculate delta V divided by delta T? I can calculate like this also, no? How much velocity is changing in 1 second? That is called acceleration, no? Acceleration ante meaning em is second ki body యొక్క velocity ఎంత మారుతూ ఉంది. That is called as acceleration. Are you able to understand? Similarly, now coming to rotational motion. Are you able to understand? If omega is not a constant, what is meant by omega? Angular velocity is not a constant. Then what we write? Then we write that alpha is present. What is meant by alpha? Alpha instantaneous can be written as d omega divided by dt. Instantaneous change in angular velocity divided by small amount of time. That is called as angular acceleration, or you can call it as instantaneous angular acceleration. So this is called what? Angular acceleration. Are you able to understand? Clear now? Similarly, if I take alpha average, then how I can write delta omega divided by delta t. This is also angular acceleration. This is instantaneous, this is not instantaneous, this is for a particular interval of time or particular angle of rotation. Are you able to understand now? That's it. So you are able to understand now how we are comparing these two. So linear motion is always comparable with rotational motion as well as circular motion also. In circular motion also same type of comparison we have done, no ma? Circular motion lo kuda ilage compare chestunam kada manam. Here also same type of comparison. Okay. In circular motion we studied about two types of circular motions: uniform circular motion, non-uniform circular motion. Similarly, in rotational motion also we will have same two types: uniform rotational motion, non-uniform rotational motion. Are you able to understand? What is meant by uniform rotational motion? Uniform rotational motion means omega should be constant. Okay. Uniform velocity means what? V should be constant. That is called uniform motion. In linear motion lo uniform motion ante meaning emi? Velocity should be constant, then it is called uniform motion. So in uniform motion, what is the acceleration? In uniform motion, what is the acceleration? Zero, there is no acceleration. Are you able to understand? Similarly, in rotational motion, when I can call it is uniform rotational motion? When omega is a constant. Are you able to understand? When omega is not a constant, then immediately alpha comes into action. Alpha means accelerated motion, no? Immediately it is non-uniform motion, or you can call it as accelerated motion. Are you able to understand the difference now? Whatever concept we study in circular motion, same concept we are studying in rotational motion also. Understood? Come on, make a note up to here. That's not right? See. So, next, already we discussed, let us write the equations also. Uniform rotational motion and non-uniform rotational motion. Clear number? For example, let us take a disk. Disk is a rigid body number, disk. So this disk is rotating about this central axis. Okay, ma? This is what? This is the axis of rotation. Okay. So it is rotating with uniform rotational motion. It means omega value is a constant. Understood now? Omega is a constant. What is omega? Angular velocity. V means linear velocity. Omega means angular velocity. Angular velocity is a constant. Angular velocity means what? It is covering same angle in same time. In first second it is covering 30 degrees. Second also it will cover 30 degrees only. Third second also 30 degrees only. So it is rotating with same angular velocity. Understood? No? So omega is a constant. If omega is a constant, then what about alpha? What about angular acceleration? 0. How can you prove it is 0? 0 ni ela prove chestaru cheppandi. Because alpha is nothing but d omega divided by dt, or you can write a delta omega divided by delta t. Like this you can write, this is instantaneous value, this is general value. Understood? No? D omega means change in omega. Change in omega. Omega value, is it changing? Omega is a constant, no? So there is no change. So delta will become 0. If delta will become 0, delta omega also 0. So therefore alpha value will be how much? Alpha value will be 0. There is no acceleration. Which kind of acceleration? Angular acceleration is not present. Are you able to understand? Okay. So if angular acceleration is not present, then I can call it as uniform rotational motion. And in uniform motion, in linear motion, we have only one equation. No? What is that equation? So displacement is equal to velocity into time. In which motion? In linear uniform motion. Understood? No? So can you say the analogous equation of this equation in rotational motion? Itanti equation in rotational motion lo cheppandi. Yes badalu? Instead of yes I will write theta. Instead of v, omega. Instead of time, time only. So theta is equals to omega into t. This is the only equation. Understood now? So in uniform rotational motion, this is the only equation which we have. Understood now? So everything we are trying to connect with linear motion. Understood now? Now once again you come to non-uniform rotational motion. So again take the same disk. Understood now? Now it is rotating with an angular velocity of omega, but omega is not a constant. Understood now? Omega value is not a constant. Understood? No? So same, this one is the axis of rotation. Okay. So if omega is not a constant, then what is alpha value? Alpha value is equals to d omega divided by dt, or you can write a delta omega divided by delta t. Okay. So omega is not a constant means omega constant kaadu ante meaning emi? It means it is varying. It is continuously varying. It means in first second it is covering 10 degrees. Second it is covering 12 degrees. Third second it is covering 14 degrees. So in every second it is covering different angles. Then it is accelerated motion. Definitely it is not uniform motion now. It is accelerated motion. Understood now? It means d omega, is it 0? D omega, is it 0? Ma? It is not 0. What is d omega? Change in omega. Omega is changing, no? So it is not 0. If omega is not 0, alpha also it is not 0. So alpha also it is not 0. Alpha is not 0 means what? It is present. That is the meaning of this one, no? Meeku తెలివే లేదు అంటే మీనింగ్ ఏమి? లేదు అని అంతే ఇక్కడ కూడా. So alpha is not 0 means what? Alpha is present. That is the meaning of this one, nama. So therefore alpha is present. Understood, no? Alpha means angular acceleration. So angular acceleration is present. Therefore this is definitely non-uniform rotational motion. Understood, no? So in non-uniform linear motion, how many equations are there? 4. Linear motion, 4 equations are there. So here also we have 4 equations. Clear, no? What are the equations we have? V is equals to u plus at. S is equal to ut plus half at square. V square minus u square is equals to 2as. Sn is equals to u plus a into n minus 1 by 2. Clear now? Same equations, how can you write in rotational motion? You can write omega is equals to omega naught plus alpha into t. Clear now? Next, instead of s I can write theta. Theta is equals to omega naught t plus half alpha t square. Okay? Omega naught means initial angular velocity. Omega means final angular velocity. Clear? Similarly, v square minus u square is equal to 2s means omega square minus omega naught square is equals to 2 alpha theta. Clear? Similarly, Sn is equals to u plus a into n minus 1 by 2 means theta n is equals to omega naught plus alpha into n minus 1 by 2. That's it. These are the equations. Understood now? So same equations we have used in circular motion also, no? Here also exactly same equations. No change. Fine? That's it. Looking like a disc, no? So consider this is a disc only. Understood, no? So this disc is rotating with an angular velocity of omega. So from the center of the disc, I have drawn one line. So which becomes the radius of this disc. And on this radius, I have taken 3 points. So first point, second point, and third point. Okay, ma'am? Then after some time, what will happen after a time of t? Okay, ma'am? After a time of t, this point 3, let us consider it will reach up to here. Understood now, ma'am? So therefore, let us consider that, okay, all these 3 points, they have reached up to here. Understood now? So this is point number 3. Okay. So where is point number 2? Point number 2 will be somewhere here. And this is point number 1. Okay, ma'am? So when this disc rotates, all these points, they will reach up to here. No? Understood now? So point 2 should have traveled in this path. Point 1 should have traveled in this path. Okay. Now in all these points, can you say some similarities and some dissimilarities? Theta is same, very good. Similarity is that all the points they have covered the same angle, no ma? Correct only, no? So let us consider first particle covered 30 degrees. Second particle will cover how much angle? 30 degrees only. Third particle also will cover 30 degrees only. Understood, no ma? So whatever may be the distance of these points from the axis of rotation, all these points they have covered same angle. Okay, angle ni cover chesna kada. So therefore what I can say here, angle covered by particles is same. This is the similarity between them. Are you able to understand? Now can you say some dissimilarities? Distance traveled by the particles is different. How? Sima. First particle, it will travel only this much of distance, no? Correct only, no? First particle will travel very small distance. Second particle will cover a bit greater distance. Third particle will cover further very large distance. Are you able to understand? So distances covered are not same, they are different. So therefore what I say, distance covered by third particle is greater than distance covered by second particle is greater than distance covered by first particle. So this is one similarity. Angle covered is same. This is a dissimilarity. Distances are same. Time is also same, no? Time is also same, no? Ma? So what is the time taken by first particle? Same time taken is taken by second also. Same time is taken by third particle also. So therefore what I can say, time intervals are also same. Time intervals are same. Are you able to understand now? Now if you see here, angle covered by each particle is same, no? Time is same, no? Theta by time? Omega. Omega is also same, no? Are you able to understand now? Every particle is covering same angle, no? And in same time. So therefore same angle, same time means omega value also same. Because omega is nothing but d theta divided by dt, or delta theta divided by delta t. So therefore what I can say, okay, omega of first particle is equals to omega of second particle is equals to omega of third particle. Okay. So when a body is rotating, what is the point here we have understood by doing all this calculation? Listen very carefully. So when a body is rotating about any particular axis, angular velocity of every particle will be same. Prati body ki edi same untundi, angular velocity will be same. Are you able to understand, ma? So consider this is the pen and I want to rotate this pen about this axis. Understood, no? Then angle covered by every particle, this particle, this particle, this particle, this particle, this particle. Angle covered by every particle will be same. Time taken also will be same. No? So therefore angular velocity also will be same. So every particle will cover same angle in same time. So that is the note point here we have to write. So therefore what is the note point I have to write? In rotational motion, clear ma? Every particle on the same body, will cover same, already we have written nama. Every particle on the same body will have same angular velocity. Are you able to understand? So angular velocity of every particle will be same in rotational motion. So this is the most important point which you should remember. ప్రతి పార్టికల్కి ఒకే యాంగులర్ వెలాసిటీ ఉంటుంది, అంతే కదా. ఒక్కొక్క పార్టికల్ ఒక్కొక్క యాంగిల్ తిరగలేదు కదా. ఎవ్రీ బాడీ విల్ కవర్ సేమ్ యాంగిల్ ఇన్ సేమ్ టైం. సో యాంగులర్ వెలాసిటీ విల్ బి సేమ్ ఫర్ ఎవ్రీ పార్టికల్. అండర్స్టూడ్ నమ్మా? Now if I observe one point here, time taken by all the three particles is same, no? Time taken is same, no? Okay, time taken is same. But the first particle is covering less distance. Second particle is covering a bit greater distance. Third particle is covering still greater distance. But time taken is same. What do you understand? Huh? First distances covered is not same. But time taken is same. What do you understand? Velocity is different. Velocities are different, no? I am traveling in a cycle with 2 km/h speed. Okay? Himanish is riding a cycle with a speed of 20 km/h. Who will cover more distance in same time? He will cover more distance. No, why? Because his velocity is greater. Understood, Nama? So time taken by all the three particles is same, but distances covered are different. So therefore this particle is having highest tangential velocity. Which velocity is highest, Ma? Tangential velocity will be highest. So therefore we know what is meant by tangential velocity, no? Velocity in tangential direction is called tangential velocity. We studied in circular motion, no? So therefore I will say this is Vt3, tangential velocity of third particle. Okay, ma? And what is this one? This is a tangential velocity of second particle. And what is this one? This is tangential velocity of first particle. Understood, no? This particle is covering greater distance, no, ma? Time taken is same. It means its velocity must be greater. So therefore I say tangential speed of third particle is greater than tangential speed of second particle is greater than tangential speed of first particle. Understood, no? Therefore what do you understand? Which body will have highest tangential speed, ma? The body which is at a large distance from the axis of rotation. Body which is at a large distance from the axis of rotation, that body will have highest tangential speed. Okay? This body, it has a very large distance from axis, no? So it will have highest tangential speed. Next tangential speed is followed by this one. Next followed by this one. Understood? This is another important point which we should make a note. So therefore what is the note point we have to write? The point which is at a large distance, from axis of rotation will have highest tangential speed. Understood, Nama? Particle axis nunchi enta దూరం ఉంటే దాని tangential speed అంత ఎక్కువగా ఉంటుంది. Understood, no? That's it. Clear, Nama? Completed up to here? Shall I rub this? So these are the most important points which you should carefully understand in rotational dynamics. If you don't understand this one, then there is no logic in entering into this topic. అర్థమవుతుంది కదా, ఏబిసిడీలు రాకుండా ఇంజనీరింగ్లోకి వెళ్ళినట్లు అన్నమాట. ఏమి లాభం లేదు. ఈ బేసిక్ కాన్సెప్ట్ అర్థం కాకుండా మనము చాప్టర్లోకి ఎంటర్ కావడమే లాభం. క్లియర్ నో? దట్స్ ఇట్. ఓకే. So therefore, what are the terms which are same? What are the terms which are not same between 1, 2, 3 ma? Time taken is same. Angle covered is same. Angular velocity is same. Understood no? Distances are not same. Tangential speeds also they are not same. So these are the similarities and dissimilarities present between first point, second point and third point. Understood no? Okay. Now, what is the equation for tangential speed ma? Do you remember? What is the equation for tangential velocity or tangential speed? V tangential is equals to omega into r. Do you remember this one? V tangential is equals to omega into r. Gurtundi kada idi? Tangential speed depends on angular velocity and distance of the point from the axis of rotation. R doesn't means only radius. R represents distance of that particular point from the axis of rotation. Okay ma? See ma, for all particles 1, 2, 3, omega is a constant no? ఇప్పుడే చదువుకున్నాం కదా. For all these particles which is a constant? Omega is a constant because they are covering same angle in same time. Okay. Because omega is a constant, can I say tangential speed is directly proportional to radius ma? Can I say? Tangential speed is directly proportional to radius. What is the meaning of that? Directly proportional to radius means? Same point here. If a particle is present at a large distance, then its tangential speed will be maximum. That's what we have proved with the help of equation also. No? Understood Nama? Sima, this point is present at a lesser distance. R value is lesser. So its tangential speed also will be lesser. It is present at a greater distance, so its tangential speed will be greater. It is present at a further large distance, so its tangential speed will be further greater. Understood no? So V tangential is directly proportional to R. So in the form of an equation, how can I write? I can write Vt1 divided by Vt2 is equals to R1 divided by R2. So I can write like this also. Okay ma? In which condition, if omega is a constant, if bodies are rotating with same angular velocity, understood no ma? Then tangential speeds and radiuses I can relate like this. Vt1 by Vt2 is equals to R1 divided by R2. Clear no? That's it. Now whatever equations we use in kinematics, same equations again you can use in circular motion also, you can use in rotational dynamics also. If it is uniform motion, displacement is equal to velocity into time. Theta is equals to omega into t. If it is non-uniform motion, 4 equations. In rotational motion also, 4 equations. Clear no? That's it. Very simple topic. Equation for tangential speed no? Okay ma? For example, this is a body rotating about any axis. Understood no? Then for example, if you take this point will have some tangential speed no? Speed in tangential direction, and if it is rotating with an angular velocity of omega and distance is r from the axis of rotation, then we know tangential speed is omega into r. Okay. Sima, if it is rotating with same angular velocity, if it means if it is in uniform rotational motion, then omega will be constant no? If it is rotating with same subara ఇదే మీకు వచ్చింది చెప్పినప్పుడు వినాలి, అర్థం చేసుకోవడమే మన కాన్సెప్ట్, నోట్స్ రాయడము ఇది కాదు. ఓకేనా? వినండి, కేర్ఫుల్గా వినండి. ఇప్పుడు అర్థం కాకపోవచ్చు, వచ్చే సంవత్సరానికైనా అర్థమవుతుంది అనమాట. ఓకే, లిసన్ వెరీ కేర్ఫుల్. Sima. So Sima, omega, if it is rotating with same angular velocity, then omega is a constant, just like uniform motion. In uniform motion, velocity is a constant. No? Here angular velocity is a constant. So if omega is a constant, tangential speed also will be constant, because V tangential is equal to omega into r. Omega is a constant, r is also a constant. Then tangential speed also will be constant. But if omega is not a constant, then it is non-uniform rotational motion. immediately alpha comes into action. Immediately ఏది యాక్షన్లోకి వస్తుంది? ఆల్ఫా, యాంగులర్ యాక్సిలరేషన్. Just like in linear motion. In linear motion, if body is traveling with a different velocity, acceleration comes into action. Here angular acceleration comes into action. So therefore, if you differentiate this one with respect to time, dvt by dt, change in velocity by time is called what? Acceleration. So this is linear velocity, linear tangential velocity. This is linear acceleration. Understood now? Similarly, omega also is not a constant, but radius is a constant. Body is present at same distance, so r is a constant. So r you take out of differentiation. So r into d omega divided by dt. Change in velocity by time? Acceleration. Change in angular velocity by time? Angular acceleration, alpha. So A tangential is equals to r into alpha. So these equations already we have studied in circular motion. Once again we are studying. Clear now? Now same equations how can I write in vector form? Velocity and acceleration, they are vector quantities only, no? Clear now? So therefore V tangential is equals to omega dash cross r dash, and A tangential is equals to alpha dash cross r dash. Understood now? And theta, angular displacement, alpha, angular acceleration, omega, angular velocity, torque, angular momentum, all they are which vectors? They are axial vectors. It means they are present along which direction? They are present along the axis of rotation. Are you able to understand? Seema. So, open the window. So consider this is the axis of rotation, this pen, and this is a body which is rotating about this axis. Understood, Nama? Body is rotating like this about this pen. Then this is the rotating body and this is the axis of rotation. This is the axis only, no? Clear, no? So angular displacement will be along which direction? In the direction of axis. Clear, no? Alpha in the direction of axis. Omega in the direction of axis. Torque in the direction of axis. L also. Angle means angular momentum. That also will be present in the direction of axis only. That is why they are called which vectors? Axial vectors. They are present along the direction of axis. And how to see their directions of vectors? We have studied now by using a right hand rule for cross product. This is cross product only, no? So to find out the direction, what I have to do? A right hand rule for cross product. Okay, ma? Let us see. See, ma, consider this is the axis of rotation. Clear, no? And the body is rotating like this. Understood, no? It is rotating in this direction, like this. Now can you say tangential speed is in which direction? Is it present above the axis or on the upside or on the downside? Which side? Upside. How can you say? How can you say? ఎలా చెప్తారు? రైట్ హ్యాండ్ రూల్ ఫర్ క్రాస్ ప్రొడక్ట్ వెక్టర్స్ ఏదైనా కదా మనం ఏం మాట్లాడుతున్నాం సార్? మేము అన్ని బట్టీనే కొడతాం, చదవమేమి మళ్ళీ తగలయ్యా. చెప్పండి. ఒమేగా డాష్ క్రాస్ ఆర్ డాష్. ఆర్ ఏబుల్ టు అండర్స్టాండ్ మా? సో దేర్ ఫోర్ V tangential is equals to omega into r. If body is moving in this direction, tangential speed will be in this direction. Give one more pen. See ma, this is the body, rotating body. Understood, no? Tangential speed will be in this direction. This is the direction of tangential speed, no? Understood, no? If this should be the direction of Vt, what is the direction of radius vector? This is the direction of radius vector. From here to here. Tail will be here, head will be here. That is radius, no? Radius vector. So r dash is in this direction. V tangential is in this direction. So therefore, if you curl your fingers, thumb should be in which direction? Thumb should be in Vt direction. Okay? It means the thumb should be like this. Are you able to understand? No? Because this is the direction of tangential speed, no? Are you able to understand? See, this is the axis of rotation and this is the rotating body. Are you able to understand? No? Body is rotating like this. It means the tangential speed is present inside the board, no? Tangential speed is in which direction? It is not present like this. It is present inside the board. Understood, no? Same concept I am explaining here also. So this is the axis of rotation. This is the rotating body. This is the rotating body. Understood, no? It is rotating like this. Then tangential speed will be in which direction? Tangential speed will be in this direction. If it rotates like this also rotates like this. Are you able to understand, ma? Okay. So therefore, if you do omega dash cross r dash, I should get Vt. Are you able to understand? If I do omega dash cross r dash, I should get Vt. Okay. Tangential speed direction I know, no? This is the direction of tangential speed. This is the direction. And this is the r direction. Okay. So place your right hand on first vector, rotate towards the second vector. Thumb gives the direction of resultant vector. That's what we studied in cross product. No? Gurtunda? Place your right hand on first vector, rotate towards second vector. Thumb should give the direction of resultant vector. Now I know r dash direction, I know v direction. Then what is the direction of omega? Omega direction. It is possible only when, clear nama, when I place my right hand like this. Clear now? This is the axis of rotation. I should place my right hand also in axis direction. This is the radius vector, no? Rotate towards the radius vector. Rotate towards the, are able to see? This is the axis of rotation. This is radius vector. Omega r. Omega dash cross r dash. What is the thumb direction? See the thumb direction. Tangential only, no? That is the direction of Vt. Understood now? So therefore, theta, alpha, omega, torque, angular momentum, all of them, they are present on the axis of rotation. Okay? It may be in upward direction, it may be in downwards direction, but definitely on the axis itself. Understood now? That is why they are called as axial vectors. Arthamaindi kada? Directions also very important, because questions may be given in vector form also. Without directions you cannot do anything. Clear? Come on, make a note. Okay. So therefore what I write, directions can be calculated. Directions can be calculated by what? Calculated by right hand rule for cross product. RHRCP. Right hand rule for cross product. Understood now? That's it.
Alpha by T dot C.
Sima, let us see this question. కొంచెం తగ్గించు. Okay. So Sima. So a uniform rod of length L is rotating about its one end in the horizontal plane. Horizontal plane means how? For example, this is the rod. Rod is rotating like this. This is horizontal plane only, no? If it is rotating like this, it will become vertical plane. But it is rotating like this, horizontal plane. Understood, Nama? So where is its axis of rotation? My axis of rotation is present at one end of the rod. This is the axis of rotation. How can I say this is the axis of rotation? Around this axis, this rod is rotating. Understood, no? So under constant acceleration alpha, and angular acceleration is given as alpha from rest position. It means initial angular velocity is how much, ma? 0. Initial angular velocity is 0. Initial tangential speed also 0. Initial tangential velocity, angular velocity also will be 0. It means it is starting from rest position. That is the meaning of this. Omega naught.
Initial angular
Okay. Initial angular velocity is 0. Okay, ma? So find its linear velocity at the midpoint after a time t0. What is the length of the rod, ma? Length of the rod is given as L. Okay. Then the midpoint means somewhere here, no? So its length will be how much? Its length will be L by 2. So at this point, what I want to find out? I want to find out linear velocity after a time of t0. Okay. So after time t0, I want to find out tangential velocity also. And also I want to find out tangential acceleration also. Similarly, I want to find out normal acceleration, or you can call it as centripetal acceleration, or you can call it as radial acceleration also. Okay, ma? This is the given question. So these three values I am supposed to calculate. Okay. Rod is starting from rest position. Understood, no? But it has some angular acceleration. What is the angular acceleration? Alpha. I want to calculate these values where, for which point? For a point which is present at the midpoint of the rod. Understood, no? Okay, now see. So first, V tangential is equals to omega into r. So what is the r value of this point, ma? R means the distance of the point from the axis of rotation. This is the axis of rotation, no? This point is present at how much distance? L by 2 distance. So I know that r value is equals to L by 2. Clear, no? But angular velocity, do I know? Initial angular velocity is 0. Initial angular velocity is 0 because it is starting from rest position. But it has angular acceleration, no? So therefore after some time body will get some angular velocity. Just like linear motion, you compare this one with the linear motion. Body starting from rest position, sunna to main. Body starting from rest position. Are you able to understand? It has some a value, acceleration is there. Therefore after some time body will get some final velocity, no? Initial velocity is 0, but if acceleration is there, what happens to velocity? Velocity continuously increases. Then after some time body will have some velocity. Same concept here also. Initial angular velocity is 0, but there will be some final angular velocity, no? How can I calculate? First of all, is it uniform motion or non-uniform motion? Non-uniform. How can you say non-uniform? Because alpha is there, no? Alpha on the kabatti, non-uniform. So therefore, which relation I can use? I can use V is equals to U plus AT, no? Because after a time of t naught, I want to find out velocity. I can use V is equals to U plus AT. What is the analogous equation of this one in rotational motion? Omega is equals to omega naught plus alpha into t. This is the analogous equation. Understood, no? So therefore omega is equals to omega naught is 0, alpha value is alpha only, and what is the time taken? Time taken is t naught. So final angular velocity is alpha into t naught. That's all, no? Okay, no? It means after a time of t naught, this total rod will be rotating with how much angular velocity? With an angular velocity of alpha into t naught. And we studied that every point will have same angular velocity, no? In rotational motion, what are the similar points? Every point on the rod will have same angular velocity. Chadunam kada already. Alpha values are same, omega values are same, angle covered is same, time taken also is same. So every point will have same angular velocity. Okay. So once I know angular velocity, now just substitute in this equation. So V tangential is equals to omega into r. Omega value is how much? Alpha t naught multiplied by radius is how much, ma? L by 2. Clear, no? So therefore what is the answer I got? Alpha L t naught divided by 2. So this is my tangential speed of which point? Tangential speed of midpoint of the rod. After how much time? After a time of t naught. That's very simple. Understood, no? So this is the equation I have used. R value I know L by 2, but omega I don't know. No? Omega value is continuously changing because rod is accelerating. Okay. So I have calculated by using kinematics and I have done the calculation. Okay. Next, what he is asking? Tangential acceleration. What is the equation for tangential acceleration? A tangential is equals to alpha into r. We have this direct formula, no? A tangential is equals to alpha into r. What is alpha value? Alpha value is alpha only. And what is the distance of that point? L by 2. So alpha into L by 2. So alpha L by 2 is the tangential acceleration of that point. That's all. Understood, no? Now what is the third point he is asking? Normal acceleration, or you can call it as centripetal acceleration. Okay. So what is the equation for centripetal acceleration, ma? We have two formulae, omega square into r also I have, and v square by vt square by r also I have. Two equations are there, no? For centripetal acceleration. You can use omega square by r also, omega square into r also, or vt square by r also. Circular motion gurtunda? Okay. So therefore, centripetal acceleration. Omega value how much? Omega value already we have calculated, no ma? So alpha square t naught square multiplied by L by 2. That's all. So this is my equation for centripetal acceleration. Calculated all the three. Understood, no ma, how we are doing? So we are taking the help of kinematics also, because rotational motion and circular motion, they are just analogous to kinematics. Equations of motion in one dimension. Understood, no? That's it. Okay, ma? So directions also we can study, ma. What is the direction of centripetal acceleration? For example, if you take any point here, centripetal acceleration will be towards the center of the circle. This is the direction of centripetal acceleration. Understood, no? or you can call normal acceleration, or you can call it as radial acceleration also. Normal acceleration will be in which direction? Where is that? No, sorry, tangential acceleration will be in which direction? So this point, it is moving in a circular path, no? This point is moving in a circular path. So tangent to that side. So this is the direction of tangential acceleration. For example, if he asks what is the total acceleration experienced by this point, then what you will do? That's all. Clear, Nama? For example, if this is the rod rotating about this axis, and this is the point which we are studying, no? So centripetal acceleration will be in this direction, tangential acceleration will be in this direction. Then total acceleration experienced is how much? This is the total acceleration, no? A. Clear, no? And angle is 90 degrees, no? So therefore, what is the total acceleration? A is equals to square root of AT square plus AC square. AT already I have calculated, no? AC also calculated, no? Just substitute here. Then I will get total acceleration experienced by that point. Understood? That's it. Okay, ma? So, this is the given question. So, angular position of a swinging door is described by this equation. Okay. So here I can say angular position means what? The angle covered by the particle. So angle covered by this door, it is dependent on time. No, it means if time is changing, this angle is also changing. Clear? No? Then you are supposed to determine the angular position, angular speed, and angular acceleration at t is equal to 2 seconds. So first of all, angular position. Okay. Angular position means what? Just angle covered by the particle. How much angle the particle is covering, that is nothing but angular position. So how can I calculate? Just substitute t is equal to 2 seconds. So 5 plus 10t plus 20t square. Clear now? So 5 plus 10 into t value 2 seconds, 20 into 2 square. So how much it is? 5 plus 20 plus 4 2s are 80. So total how much ma? 105 radians. Clear? So this is the angle covered by the particle or angle covered by this swinging door. So it is covering how much angle? 105 radians in how much time? In a time of 2 seconds. That's it, no? Similarly, next he is asking about angular speed. Angular speed. What is meant by angular speed? Omega, no? So omega value how can I calculate? Omega is equals to, we know it is d theta divided by dt. This is the equation of angular speed, no? So just differentiate this one. So therefore d by dt of, what is the theta value which is given? 5 plus 10t plus 20t square. Okay. Differentiation of 5? 0. 5 is a constant number, its differentiation is 0. Differentiation of 10t? 10. Differentiation of 20t square? 20 into 2 t power 2 minus 1. This is how I write, no? Differentiation of x power n is n into x power n minus 1. Clear now? Now do this calculation. So it is a 10 plus 40t. That's all now. So this is the angular velocity equation. But he is asking us to find out angular velocity at t is equal to 2 seconds. So substitute 2 there. So omega is equals to 10 plus 40 into 2. So how much? 90. 90 radians per second. That is the angular speed which I got. Okay. Then he is asking us to find out angular acceleration also. No? So how can I calculate angular acceleration? Angular acceleration nothing but alpha, no? So how can I calculate alpha value? Alpha is again differentiation of angular velocity with respect to time, d omega divided by dt. So this is displacement, velocity, acceleration. Angular displacement, angular velocity, angular acceleration. That's all. So omega value already I have now. What is the omega equation I got? 10 plus 40t. Clear now? So 0 plus the differentiation of 40t will become 40. So alpha is equals to 40 radians per second square. Okay. So we know the unit of displacement, no, it is meters. In angular motion it is radians. Clear now? For velocity it is meters per second. In angular motion it is radians per second. In linear motion acceleration is meters per second square. Here it is radians per second square. That's it. Understood now? Just like a linear. So see here. So a solid body is starting rotation about a stationary axis. Any body, any regular body or irregular body. Okay ma? So consider any disk, ring, anything. So it is rotating about this axis of rotation. Are you able to understand? So with varying angular velocity, because acceleration is there, no, angular velocity will be continuously changing. Okay. So with an angular acceleration, alpha value is how much given? Alpha value is equal to k into t. It means if time is changing, angular acceleration also is changing. So this is not uniform motion. Similarly, this is not a linearly accelerated motion also. Because alpha, is it a constant? Acceleration, is it a constant? If it is a constant acceleration, we can say it is uniformly accelerated body. But alpha value is also changing. No? So it is a non-uniformly accelerated body, definitely accelerated body. Are you able to understand? Accelerated motion. Uniformly accelerated or non-uniformly accelerated? Non-uniformly accelerated, because alpha value is also changing with respect to time. Are you able to understand? Then what he is asking, how soon after the beginning of the motion will the total acceleration vector of any point or any arbitrary point form an angle 60 degrees with the velocity vector? What is meant by velocity vector? Velocity vector means tangential velocity. No? This is called velocity vector. For example, if you take this point will have two accelerations. Already we studied in circular motion. No? One acceleration is it will have centripetal acceleration, and one more acceleration is it will have tangential acceleration also. Two accelerations are present. Are you able to understand? Ma? So body will have two accelerations. Then what is meant by total acceleration? Total acceleration means what? Total acceleration means resultant of these two accelerations, centripetal acceleration as well as tangential acceleration. Clear now? So if you take the resultant of centripetal and tangential, then we can say this is the net acceleration, this is the total acceleration, A. And how can I calculate A value? A is equals to square root of AC square plus AT square. Already we studied many times now. Total acceleration is square root of AC square plus AT square. Now this is the net acceleration. So this net acceleration should make how much angle? It should make an angle of 60 degrees. That's the meaning of this one now. So this acceleration, it should make an angle of 60 degrees. So angle between total acceleration and velocity vector. Okay, ma? Then what is that time taken that I want to calculate? Time only, no, he is asking how soon. It means what is the instant of time at which the angle between acceleration and velocity vector is 60 degrees. That is the question. Are you able to understand? Arthamautundi kada, or shall I draw a bigger diagram? Clear, ma? So this is velocity vector, this is centripetal acceleration, and this is tangential acceleration. Clear, ma? This is the total acceleration, net acceleration. So angle between net acceleration and velocity vector should be how much? 60 degrees. So for that thing to happen, what is the time taken that I want to calculate? Understood, no? So what is the equation of centripetal acceleration, ma? Centripetal acceleration. Centripetal acceleration is omega square into r, or you can write v square divided by r. These are the two equations of centripetal acceleration. Tangential acceleration, we can write dvt divided by dt, how tangential speed is changing with respect to time. Or also you can write alpha into r also. These are the two equations. These equations you should by heart now. You should learn them very carefully. Okay. So these are the two equations which I have. Are you able to understand? But omega value, is it given? No. Tangential speed, is it given? No. Alpha, is it given? Alpha is given. Clear, no? But omega is not given, v also not given. So what can I do? What can I do? So from alpha value, can't you find out omega value, ma? How can you find out? So already we have a relation, no? What is the relation? What is alpha? Alpha is equals to d omega divided by dt. Change in angular velocity by time is called as alpha. Clear no? So from alpha I want omega. So therefore what I will do? So it is changing with respect to time only, no? So I have written with respect to time. So therefore k into t is equals to d omega divided by dt. So therefore d omega is equals to kt into dt. I can write like this, no? If I want omega, what I have to do? Integrate on both sides. If you integrate on both sides, then what I will get? Integration and differentiation will get cancelled. So therefore omega is equals to integration of kt with respect to dt. Omega k is a constant number, take it out of integration. So integration of t dt. Integration of t dt is how much? T square by 2. That's all. No? So I calculated omega value. No? So what is omega value? Kt square divided by 2. So once I calculate omega value, now I can calculate a centripetal acceleration. No? Similarly, if I know centripetal acceleration, at also I can calculate number because alpha value already it is present. Are you able to understand? Now substitute. So therefore, so centripetal acceleration is how much? Omega square into r. Omega value kt square by 2 whole square multiplied by r. Clear number? So therefore k square t power 4 divided by 4 multiplied by r. This is centripetal acceleration. Similarly, tangential acceleration is alpha into r. Alpha value k into t. So k into t multiplied by r. Are you able to understand? Then what is the total acceleration? Total acceleration a is equals to square root of ac square plus at square. So a is equals to square root of centripetal acceleration is how much more? So k square t power 4 divided by 4 into r whole square. Okay, plus at square. At is kt into r whole square. Clear no? So this is the total acceleration. Are you able to understand? So therefore we will try to simplify this one. Then what he is asking, what will be the total acceleration angle between so see now. So this is the 60 degrees which he is asking, no? Are you able to understand? No? Now this 60 degrees is the angle between what? This is the angle between total acceleration, velocity vector as well as tangential acceleration also. If this is AC, this is also AC, no? If this is AC, this is also AC. According to which rule? Parallelogram rule of addition. Are you able to understand? So if you want to tan 60, just you can do one thing, no? Without calculating all this value, can you take AC divided by 80? Definitely I can take AC divided by 80. This is a right angle triangle, opposite side divided by adjacent side. So AC divided by 80. What is the centripetal acceleration? What is that? Centripetal acceleration. So it is k square t power 4 into r divided by 4 divided by tangential acceleration is kt into r. Now what are the terms which can get cancelled? So r and r get cancelled. Tan 60 value is root 3 number. So root 3 is equals to k and square also get cancelled. T and here I will get cube. So k t cube divided by 4. That's all, no? This is the value which I can get. So therefore t cube value is how much more? T cube value is 4 root 3 divided by k. So therefore t value is cube root of 4 root 3 divided by k. That's all. 4 root 3 divided by k. So in that time, definitely I can say the angle between total acceleration and velocity vector will be how much? 60 degrees. Understood, no? That's all. Like, see this question. So a solid body starts rotating about a stationary axis with an angular acceleration alpha is equals to alpha naught into cos theta. Okay, this alpha naught you can take it as a constant, and so here one thing you can see now, if theta changes, alpha also changes. That's all. No? So angular acceleration is dependent on what? Theta. Displacement, angular displacement. Theta is angular displacement only. Okay. Then find angular velocity of the particle as a function of theta. Omega value we are supposed to calculate. Now let us study about linear motion. In linear motion, okay, we have acceleration. In straight line motion, we have acceleration. And what is acceleration? dv divided by dt, change in velocity by time. We have one more equation for acceleration. No? What is that one? v dv divided by dx. This also we have. Two equations unnai kada acceleration. We use this equation in which condition, and we use this equation in which condition? We use this one when velocity is changing with respect to time, and this relation when velocity is changing with respect to position, displacement of the particle. Time to party velocity marutunte ee equation. If velocity is changing with respect to displacement, then we use this equation. Already we studied. Similarly, same equations, how can I write in rotational motion? In rotational motion, how can I write? Instead of A, what I can write? Chapali, alpha. Clear, no? D, instead of V, omega. Divided by dt. Clear, no? Similarly, second equation, again instead of A, alpha. So instead of V, omega. dv, d omega. dx, d theta. That's it. Clear, no? Ante kada. So this is a displacement, this is angular displacement. Are you able to understand? Now this equation we are supposed to use, this equation we are not supposed to use, because if you see in the equation, alpha is dependent on theta, it is not dependent on time. Okay, now use the relation. So therefore I will use alpha is equals to omega d omega divided by d theta. I want omega only, no? So alpha into d theta is equals to omega into d omega. Okay, so integrate on both sides. So integration of alpha value is how much? A naught into cos theta into d theta is equals to integration of omega into d omega. Understood? So therefore A naught is a constant, take it out of integration. So integration of cos theta is sin theta. Clear, no? So sin theta is equals to, and A naught also we have, no? Alpha naught to sin theta is equals to integration of omega square divided by 2. That's all, no? And he is asking omega value only, no? So omega square is equals to 2 alpha naught sin theta. So omega is equals to plus or minus square root of 2 alpha naught into sin theta. That's all. That is my answer. Okay. So answer may be plus also, answer may be minus also. Because minus 2 into minus 2 plus 2. Plus 2 into plus 2 also, plus 2. Are you able to understand? So plus root 2a naught into root 2a naught sin theta, again you will get this value. Minus value also will give same value. No? So answer may be plus also, answer may be minus also. That's it. Very simple. So point is that which equation you are selecting, that is very important. So here in this equation, alpha is not depending on time, no? So this equation you cannot use. Alpha is dependent on displacement, angular displacement. So this value and this values only you are supposed to use. Clear? That's it.